Hello, everyone. I'm Chen, General Manager of Computing and the AI Technology Group of MediaTek. MediaTek is a fabless semiconductor in developing leading-edge SoC for mobile device, home entertainment, automotive, and IoT. I believe that many of you have listened to quite a few talk about robots. After this event, I'm getting more ready to live with more robots in the near future. Just like we are having more and more smart device with us. Actually, we got a new one, right? The Bose headset. So maybe next year we get a toy robot. Yeah. And talk about robot. Robot need to deal with real-time dynamics and also need to respond to the environment immediately. So robot need to have its own local and self-contained AI. That means it needs to process the AI and the machine learning task locally without relying on the cloud. So we call this kind of local on-device AI simply as Edge AI. So today I'm going to talk about how Edge AI is going to transform smart devices or redefining our smart devices. So I will talk about, first I will talk about the technology evolution that enable the Edge AI technologies, named the opportunities that created by Edge AI. After that, I will share practical examples built on top of MediaTek Helio P90 SoC, which is for smartphone that is most powerful Edge AI SoC so far. And then I will talk about the design challenges of Edge SoC design to enable more complicated applications on the device. After that, I will present the technology I see that could be able to address these challenges. So these are two AI functions, face unlock and the voice assistant that many of us use frequently. Then what's the key difference between these two applications from user experience perspective and or from technology perspective? Anyone would like to answer? Okay. Face lock actually it get the AI processed locally at the device. However, the intelligence of a voice assistant mainly from the cloud. So it results in the difference in user experience. Face lock, it stores the information locally at the device. So it definitely has good privacy, and also it can be available anytime without relying on the network. So it is available anywhere, and definitely you can see the response time is much faster than the voice assistant. So so you can see that's the advantage of Edge AI. And we know deep learning, deep neural network introduced in 2012, it can achieve human-level accuracy in 2015. Due to the success of a deep neural network, then it creates lots of great business opportunities. That's why AI has been widely used in our daily life, such as robot and surveillance, transportation, and so on. However, deep neural network achieve good accuracy at the cost of high computation complexity and also high memory usages. Therefore, at the beginning stage of deep learning, cloud-based is preferred. Let's look back to the 2014. BGG16 is the most well-known deep network at the time, and here the number 15.5 gig max and 34 megaparameters just stands for the complexity of the network, where max stands for the multiplication accumulation operations. So running BGG16 on cloud at that time, the response time ranging from 250 to 1250 milliseconds, where computation time just take up 50 milliseconds, and the response time is mainly dominated by network latency. However, compared with the iPhone 5S at that time, it takes longer. It needs 3 seconds. So obviously, cloud is a better choice at that time. Here I mainly talk about the inference, not the training. Then as the algorithm and the hardware advanced in 2016, the network evolved to Inception ResNet. You can see the number here. I'm not going to go into detail. You can see the complexity of network is reduced more than half. So running this network on cloud, though the computation time is reduced to below 20 milliseconds, however, it is still dominated by the network latency, so no much improvement. However, the device iPhone 6S, the computation time is reduced to 50 milliseconds. It is equivalent to the response time. Therefore, 50 milliseconds is generally good enough for most users and most applications. So here, actually, this shows that deep learning inference on device become feasible. So in 2016, for the application like image classification, that device is a better choice named cloud. So let's look back the historical evolution of deep neural network. Here, the vertical axis is the accuracy, while the name here, for example, in 2015, the most well-known network is ResNet 50. Okay, so and the circle size stands for the computation complexity of that network. So you can see the trend here. The first trend is during 2012 to 2016. This 4 years, the main focus is try to improve the accuracy to meet the good user experience. So you can see that the accuracy is improved by around 24%. However, the complexity is increased by 10 times. So at this time in 2016, the complexity is still too high to enable more complicated application on device. Then after 2016, because the accuracy already good enough, so a branch of research start to reduce the complexity of the network while keep good accuracy. This is equivalent to improve the efficiency in the using of computation or memory bandwidth. So you can see here, comparing 2017 MobileNet V1 with the 2014 BGG16, the computation complexity in terms of Gmax is reduced by 27 times. And even more in 2018 MobileNet V2, the reduction even pushed to 50 times. So you can see here, because the fast involvement of the network architecture that makes Edge AI become much more feasible and enable more complicated applications. Let's have a more comprehensive comparison between cloud and edge. Cloud, you can see, definitely it has much richer resources in terms of computing, memory, or thermal budget. However, edge has lots of advantages that cloud cannot compete with. For example, privacy. I believe that people don't want, if you have choice, you don't want to upload your data to the cloud. For example, browser provide a function for you to delete your historical data, but it's better not to upload it. So privacy definitely, and also it is edge is always available. For example, we are here. I think you feel that the network latency is awful, right? And definitely, and also no network latency can enable real-time applications. And uploading the data from edge to the cloud consume huge amount of network traffic and energy. So actually, edge AI is much more cost-effective. However, you can see the trend that more and more inference AI will move to the edge. However, this does not mean edge AI will totally replace on the cloud. Training and more complicated AI will still remain at the cloud. In the long run, the best solution would be cloud and the edge. They collaborate in a complementary way. So with edge AI, it is in 2018, last year, device can afford more than 100 gigameg per second. So it enabled a visual perception function like image classification, object detection. In this year, device can support 1 terameg per second. So object construction like image segmentation and the depth estimation become feasible. And we expect that it is evolving toward 10 teramegs per second so that it can enable the image quality enhancement like super resolution and noise reduction. So with edge AI, that it can bring user experience of existing product to the next level. Taking smartphone as an example, last year, face unlock has become a basic feature. And this year, some of the high-end smartphone camera effect like video bokeh become a popular feature. And I believe that in next year, the image enhancement for photo like noise reduction will become a very important feature in a flagship. Similarly, AI has been applied to improve the picture quality of TV. So in this year, I expect that a scene-based approach will be available in the market. That means you don't need to set a PQ mode manually. Set a sports mode or cinema mode. The TV will detect the scene in a real time and optimize the picture quality. And looking forward to the next year, it will evolve from scene-based to the object-based. That means in the same frame, no matter it's a human face or green grass or blue sky, this object can be optimized. Their PQ can be optimized separately. And in the future, it will evolve toward the image quality enhancement, like super resolution. Right now, 8K TV is available. However, most content are still in Full HD. So AI is good to do the resolution upscaling. However, according to our study, the complexity is still very high. So in addition to transforming, to bring the user experience to the next level, edge AI is transforming smart devices and create new opportunities. So in home right now, vacuum cleaner robot is very popular. It is evolving into a home assistant in the future so that it will be able to understand the 3D environment, and it can self-position, and it can interact with people in a natural and proactive way. For example, when you are leaving your home, but it start to rain outside, your home assistant will come to you to remind you it is raining and ask you whether you want to bring a raincoat or umbrella with you. So not just hello, Alexa, and so on. And definitely, definitely it can do the routine tasks like housekeeping, elderly care, and so on. And in workplace, future video conference will be able to recognize all the attendees and get a camera focus and the run and the pan to the speaker automatically. And moreover, it will be able to do the real-time voice-to-voice translation. I think this is the most function that I hope most, yeah. And it can make the meeting minutes or meeting summary, find the insight, and send the meeting minutes to the attendees in their language. And for cars, currently there are quite a few driver assistant functions available, such as lane departure, blind spot detection. And it is evolved toward autonomous driving. Actually, autonomous car is kind of a robot, autonomous machine. Autonomous driving system need to process huge amount real-time videos. And when confronted with a hazard, only a few hundred of milliseconds allowed to detect and make a decision before activating the vehicle control. So autonomous system actually it demand low latency and high computation edge AI capability. So I will talk about the design challenges of SoC because you can see there are lots of great opportunities. However, these emerging applications will have a higher and higher complexity that demand device to provide higher AI capability. However, we find it's become more and more challenging to further increase the edge AI capabilities. Deep neural network, as I mentioned, it is highly computation demanding and also consuming high memory bandwidth. Moreover, generally, to implement function, it needs to have a multiple network running concurrently. For example, you need to detect the face and do the segmentation, and also do the depth estimation, and so on. So generally, there will be multiple network running concurrently. Moreover, you also need to run the whole system. So you need to have a multiple processing engine like a CPU to do the flow controls, GPU for the graphic, and modem, Wi-Fi, camera, and so on. You need all this processing engine to run concurrently at the same time. However, this processing engine generates heat and consume memory bandwidth. So actually, the requirement is very demanding. However, device is inherently very resource constrained. So you can see this is the design of edge AI SoC is become more and more challenges. So the key here is to design such SoC, you cannot just look at, many people ask me, how about the APU AI processing engine in your chip? Actually, the most important thing is you need to consider the whole system together instead of just looking at the AI. So you need to understand the applications, know the algorithm, and know your hardware, and do the co-optimization all the way from system algorithm to the hardware. Next, I will show the practical applications built on top of MediaTek Helio P90. The first demo is to use AI to reduce the noise of camera, especially in the low light condition. I believe that you must have the experience when you feel touch or if you're romantic, you want to take a photo, but generally it's in a low light condition. Yeah, right? So, however, take a photo in a low light condition is the most challenging to the camera, especially to the mobile camera, because of the form factor, the sensor size is very tiny. So the amount of light received by the sensor is very low, especially in the low light condition. So generally, the system need to set the amplifier of the sensor noise to a very high level as compared to the normal condition. However, the intrinsic noise of the sensor is amplified at the same time. So the picture generally you get is very noisy and very disappointing. However, from theory, it is generally very difficult to remove a noise while keep the detail, because you apply a filter to filter out the noise, then the detail also gone. Okay, so next I will present how we apply AI to do the noise reduction. This is the exemplary thing that we do the experiment to test the AI noise reduction. Yeah, I'm not sure. I think you can see there's a beauty sitting there, right? And there are several camera settings there. And maybe there's an engineer there, but it is not me. I hope it's me. So we set this to test the extreme case of the camera. Okay, this is the two pictures we got. Which one is better? Actually, the result always depends on the display, right? But from my monitor, it is obvious that your side is right one. Right one is definitely better than the left one. So the right one is based on AI. However, the left one is based on traditional noise reduction techniques. As you can see that the right one, the noise level is much lower, while it reserve more detail. You can see that the hair, the detail of hair, and also the face, the nose, the mouth, and the eye is much more clear than the left one. And there are many noise contour on the left-hand side. And also, the color saturation is much better for the right one. So in many camera design, there's a trick that they try to make it less noisy to make it darker. So in most cases, you can try to use your camera to take the night shot. It is darker because try to make it less noisy. That's the trick. So that's the result we got. So I'd like to talk some more about the technology difference between these two approaches. That's the conventional noise reduction approach. It is based on the principle of self-similarity and the zero mean noise. It assumes the noise is a random white with zero mean, so that you can add up the area of high similarity and then take the average. So if the noise has zero mean and is white, noise can be removed, right? This can be applied in a single frame. We call it spatial filtering. You can also apply it in a temporary consecutive frames. However, there's two issues with this approach. First, it's difficult to judge the similarity of regions by hand-coded rules. And the second, generally, the noise of a sensor is not randomly white, and the mean is not 0. So this limited the performance of this traditional approach. Instead, the AI approach is data-driven. So to do this, we select a deep neural network. Then we start to train it. We needed to build a database consisting of a pair of images. One is from the smartphone you want to design. The other is from a high-quality camera with much lower noise. Then we start to train the parameter of the neural network. We input the image, and the camera capture the image and feed it to the deep neural network and get the denoise image. Then we train the parameters by the difference between the high-quality picture and with the denoise picture. Then we use this difference to train the network until the denoise, the DNN output, looks very similar to the high-quality picture. Then when it converges, that means the output of a deep neural network looks like the high-quality camera. That's the approach that we used. So when the training finished, you get the network that is ready for the use, right? However, this approach has a big challenge that the computation and the memory usage is very high. So the response time takes more than 10 seconds. It is not affordable or cannot be accepted by our customer or our user. So we need to think out how to improve it. So here we use another technique called network quantization technology, which is pretty well known in the deep learning technology. The idea is initially most deep learning algorithms are designed in the data type of 32 bits. But actually, human like us, we can do the image segmentation, recognize the object, or have the depth estimation without floating 32-bit computation capability. So that implies we can use fewer bit widths to do the same thing. So in our experience, that we try to quantize, reduce the bit width from floating 32-bit to integer 8. Then we can still keep good accuracy, while the computation complexity is reduced significantly. So this is the result we got that take ResNet as an example. Compare integer 8 with 14.32-bit. The energy is reduced by 11 times, and the memory is reduced by 4 times. So this is the result we got. Originally, we have a 14.32-bit data format algorithm. Then the time takes 6 seconds. Then we apply the quantization technology to make it into 8-bit integer. Then the execution time reduced by 40% to 3.6 seconds. Then it is still too long because the maximum time user generally can accept is 2 seconds. So we apply another technology is to call network pruning, is to reduce unimportant or redundant weight in the network, so that we can reduce the response time that is shot to image time to 1.8 seconds. So as you can see here, this is an example how we optimize from understanding application and do the algorithm and the hardware co-optimization, apply the techniques to do network reduction. Then we can get an improvement by more than 3 times. That's about the AI noise reduction. Next, I'm going to show another example. It is real-time 3D pose detection. This setup is as you can see there, there's a smartphone layer that is powered by MediaTek Helio P90. And the camera will capture the denser, its pose and its action, and copy to the robot through Bluetooth. Okay, let's look at this demo.
MediaTek Helio P90 and APU 2.0 are taking AI movement tracking to the next level with real-time pose tracking. The virtual avatar demo will map your movements onto a personalized 2D avatar, which will follow your movements whatever you do. The AI robot demo allows your pose to be copied by a robot, and real-time human pose tracking can accurately follow several people at the same time. Let's see them in action.
Okay, here maybe you have seen similar demonstration in some other place. However, here's a key difference. Before I move forward, actually this kind of pose detection is essential function to enable many applications. This is interesting. Sorry. This is interesting application of, let me play it again. So, okay, it's fine. Actually, we also applied it to do an AR sensing game, and let me see whether I can make it. Okay, it's fine. So the pose detection can be also applied to develop AR sensing game, and also it is useful to detect the human behavior that is useful for the ADAS or surveillance or elderly care. Okay, yeah, here you go. So you can see that the avatar follow the denser pretty well in a real time, and it can move backward and forward, so it's a 3D. However, the challenging thing is it is done by a smartphone, not by a PC or by a GPU server. So the key point here is the algorithm must be processed within 33 milliseconds per frame to get the real-time feeding, and also it is 3D. And what's under the hood? Actually, the technology under this demonstration is very complicated and very challenging. So you can see there are many processing engines running concurrently. The Bluetooth to control the robot, and the camera to capture the image. CPU to do the flow control, GPU graphic rendering, and the APU to detect the face, detect the pose, also do the 3D estimation. And you need to have a sensor and Wi-Fi to mirror the smartphone to display it over the TV. And definitely there's a codec. Important thing here is all the processing engine consume memory bandwidth and generate heat. So, however, the smartphone itself is very resource constrained. So, in this chip, it needs to provide 1.1 tera max per second to get the pose detection algorithm done within 33 milliseconds. And also, it needs to integrate all these important processing engine, including CPU, GPU, definitely APU, and 5G modem, Wi-Fi, and so on in this chip. However, the system is for smartphone. It's a real smartphone. So the memory bandwidth allowed is only 12 gigabytes per second. And for smartphone, the surface temperature of smartphone must be kept below 45 degrees C, because when it is higher than 45 degrees C, people feeling burned. So because of this country, I believe that you don't know that your smartphone, actually there's some power temperature control mechanism inside your smartphone. So actually when it gets higher than 45 degrees C, your performance, the system will lower down your clock frequency. So the performance getting poor. So because of this limitation, the whole system power allowed whole smartphone only 5 watt. And what allocated to the SoC is below 2.5 watt. So you can see that this is truly challenging to SoC, which the form factor like this. That's our true chip. Like this to run this complicated applications. P90 launched December of last year, and its smartphone, our customer will get the product launch, I think by next week. So if let's make a comparison, if we want to implement the post-detection function by a PC, you need the system need to consume 200 watt, and the memory bandwidth take 320 gigabyte per second, and there's no more 4G modem function. So if you want to have a mobile function, you need to add another hotspot for 4G. So you can see that this kind of high integration edge SoC can truly make the smart device truly different. Okay, so that's the 2 demos that I'd like to share with you. Next, I'd like to switch to talk about the key technologies to get device can run more sophisticated applications. There's most important thing is try to improve the efficiency of to run the deep learning workload on device, especially in terms of the use of memory and the use of power. And that definitely time to market, because developing AI application is usually very time consuming. So I'm going to talk about, the first one is specialized hardware and the system design. The second is the design automation. And the final one is the integrated and flexible SoC platform provided by MediaTek. Okay, deep learning is workload. It's actually a new type of computation consisting of many repetitive operations like convolution. It's consisting of many multiplication and accumulation operations. Definitely, it can run on top of a general purpose processor like a CPU, GPU. So I think you are familiar with the GPU. However, there's a better way to do it. In P90, we design a specialized hardware that optimizes for the frequently used operations, so that in our result, taking the face detection algorithm as an example, comparing the APU versus CPU, the speed can be improved by 20 times, while the power is reduced by 55 times. Another important approach is to design to optimize it from the system point of view. Generally, an application consists of workload of different characteristics. Not only deep learning workload, it consists of control and also graphic or communication and so on. Definitely, there's multiply accumulation operations. So one size fits all is not the best solution. There's a better solution is you build a mechanism we call is the heterogeneous runtime, so that this runtime can dynamically allocate the workload to the right processor according to its characteristic. For example, if it is control workload, CPU is the right one to process it. And if it's multiply accumulation, definitely the APU is the right choice. So with this heterogeneous computing technology, then the system can get the performance maximized while having the best energy efficiency. And another important thing is that these three processors, they can run concurrently, so the computation resource of the system are fully utilized. And moreover, that this kind of heterogeneous system provide a good flexibility to support a fast evolving neural network, because when there are new operations coming up, then that are not supported by the APU, then we can have a CPU, a general purpose one, to support that, to enable it. Okay, that's about the hardware design and the system. Next, I'm going to talk about how to develop edge AI, the process to develop the edge AI. So for the target application that you want to develop, first you need to set the accuracy target for the application, right? Then you need to select a network first. Then you train the weights by the label data. Then you get a network with trained weight. However, to get it fit into the resource constraint hardware, you need to apply the network reduction techniques such as quantization or removing an important weight. Then you get the target network to map onto the hardware. At this moment, you need to set the hardware configuration, make the hardware resource allocation to get the hardware and the algorithm software match well, so that you can get the best performance. So at this moment, you get the performance. However, we confront with this problem that you can see that the hardware constraint is not considered in the algorithm or network development stage. So if the performance cannot meet your requirement, you need to go back to redesign the network, do the modification, and then you need to have many heuristic try and error iteration to achieve the accuracy or the performance you want. That can take days or even weeks. Moreover, this kind of optimization is hardware dependent. So if you want to get your application running on another hardware platform, you need to repeat the same process. So this is truly a very time-consuming process. So there's a better way to do this. So a better way is to develop an algorithm that can do the design automation. And the design automation is platform aware. So this approach that at the beginning we provide the objective in terms of accuracy and the performance. At the same time, we also give the constraint of the hardware. It includes the computation resource of APU, CPU, GPU, and so on. And also the memory bandwidth, memory capacity, and the thermal budget allowed by this device. Then with the objective and the constraint, then the automation algorithm will select an initial network. Then it will do the training, network reduction, hardware resource allocation automatically, and do the iteration until the result meet your objective under the resource constraint. So with this approach, you can get a better performance, accuracy, and more energy efficient. And also, you can shorten much the time to market. Let's look at the result we have. We take the Inception V3 for image classification as an example, and this example is from our P90 platform. First, we start with running the Inception V3 on CPU manually. Then we migrate it to run on APU, also manually, we can get a 14 times speed up because the APU is optimized to accelerate the deep learning workload. Then at this point, we found that it is very difficult to further optimize the performance manually. So we developed an automation algorithm to try to do the optimization. Here's the result we get. If our goal is to improve the speed while keeping the same accuracy, we can get 3 times improved in speed while the accuracy remains unchanged. If accuracy is the priority, then we get a result. We can improve the accuracy from 78% to 85%, while the execution time remains around 15 milliseconds. Also, this algorithm allows you to do accuracy performance trade-off optimization by adjusting the weight of the accuracy or performance. So as you can see that also the engineering resource is reduced by 70%. So the automation design is a very active research area. Next, I'd like to introduce NeuroPilot, that is MediaTek Edge AI platform. We provide a high integration SoC, integrating APU, CPU, and so on, depends on the requirement of product. We also provide a software stack that enabling heterogeneous computing. And we also provide a SDK and the tools to do the platform-aware design automation. And also we provide a tool to do the system profiling, so the developer know the CPU load and the GPU load, whether it's bound by CPU or bound by memory, so that the developer, they can do the change to their network to make it is not bound by the resources. That is very important to get the best system performance and the best energy efficiency. Moreover, our platform provides flexibility to add customized operand, because when in our cooperation with our customer, there are still new deep network coming out. So they want to have to support new operations. So our platform provides flexibility to add customized operands. And we also support to the main deep learning framework such as TensorFlow, Caffe, and so on. I think the support to the framework can depend on the user requirement. We can support that. Our design is also across different OS, including Android, Linux, and real-time OS. And one important thing is our platform, software platform, it is based on, we want it to get the application ported to different hardware very easily. So you can get it ported to a good portability to different hardware platform. So MediaTek, we are the leader of SoC design. So MediaTek, our product cover from smartphone, tablet, TV, set-top box, and also the infotainment and the parking assistant of the automotive. So we have the broadest coverage of leading technologies across mobile, home, and automotive. There are 1.5 billion MediaTek power devices sold per year. So with a rich portfolio of this leading technology in computing, communication, multimedia, as well as AI, we believe that MediaTek is perfectly positioned to bring AI everywhere by equipping smart device with AI capability. Okay, let me wrap up. Because as you can see that the technology keep on advancement rapidly, so there will be more and more sophisticated edge AI application enabled on the device. And memory and the thermal will be the most challenging resource constraint to the device because the memory technology cannot cope with the computing technology, the improvement. And also the thermal solution, the improvement is very, very slow. So efficiency in terms of memory and also the power that are the most critical factors. So, and because of this, specialized hardware design and the system will become a common practice for high-performance device. And to shorten the time to market and get your system optimized, design automation is a very important research area that is keep on going. Okay, let's conclude my talk. Thank you for your attention.